the third ever interstellar object observed for Earth, is currently racing through our solar system. Now, astronomers have captured that moment live. Tonight, on The Future of Everything, we've got 3i Atlas updates, and maybe even our best shot yet to clearly see the third interstellar object ever detected passing through our solar system. Far beyond the orbit of Jupiter, in the deep black, where the sun's warmth is little more than a whisper, something extraordinary occurred. The interstellar object, known as 3i Atlas, a traveler from another star system, became the stage for one of the most electrifying cosmic events ever observed. What astronomers saw defied every expectation. A sudden, violent flash that made the object blaze like a miniature sun, glowing with the intensity of a nuclear reactor. For a brief, surreal moment, an icy body drifting through the void transformed into a spectacle of radiant fury, as if the universe itself had struck a match in the dark. Before we start, smash the like and subscribe buttons for more updates. The first signs of something amiss came from automated survey telescopes sweeping the outer solar system. 3i Atlas had been catalogued as a faint, unassuming wanderer. Its path was traced as it coasted silently on an elongated trajectory from the interstellar void. Yet one night, its brightness spiked by several magnitudes in seconds. Not days or hours, but seconds. Instruments recorded a burst of light so intense that it saturated detectors designed to capture faint glimmers from distant worlds. Astronomers scramble to confirm the reading, suspecting a glitch. But when independent observatories across the globe registered the same event, disbelief gave way to awe. Something enormous had struck 3i Atlas with unimaginable force. Unlike the gentle cometary outgassing that had once been associated with the object, this was a cataclysmic impact, a kinetic assault that ripped through its structure and released energy on a colossal scale. 3i Atlas, a relic of another sun, had met something massive enough to punch through its outer crust and ignite a chain reaction of heat, radiation, and fragmentation. The glow wasn't a trick of reflection. It was self-luminous, a product of atomic fury. Whatever had collided with it unleashed a cascade of energy that rivaled the brilliance of the brightest supernova remnants, but on a miniature, eerie scale. The object itself, long thought to be composed mainly of frozen volatiles and interstellar dust, became an inferno. Observers reported a spectrum dominated by ionized metals, with streaks of exotic elements that hinted at a composition never before seen in our system. The heat radiating from the impact zone was so intense that it vaporized surrounding material, creating a shimmering halo that expanded outward like the corona of a star. For the first time, astronomers were witnessing an interstellar collision in real time. The meeting of two travelers in the dark, one from beyond the sun's reach, and the other possibly a rogue object from our own cosmic neighborhood. The scale of the event was staggering. When the kinetic energy of the impact was estimated, it rivaled the combined power output of 1,000 nuclear detonations. The calculations painted a picture of an object perhaps several hundred meters across, an asteroid or remnant fragment that had crossed paths with 3i Atlas at hypervelocity. At such speeds, even a small mass could deliver devastating energy upon impact, compressing material instantaneously to temperatures and pressures sufficient to trigger nuclear-like emissions. The sudden glow was not from fission or fusion in the conventional sense, but from the intense excitation of atoms stripped bare of their electrons. Plasma roared into existence in the vacuum of interstellar space. For a brief span, 3i Atlas was no longer a faint dot on astronomical charts, but a beacon. Instruments from ground-based observatories to orbiting telescopes registered the flare, while radio arrays picked up a burst of electromagnetic noise that rippled through frequencies in ways eerily reminiscent of man-made reactor signatures. The analogy wasn't lost on scientists. What they were witnessing looked, in every measurable way, like a reactor core running wild in the cosmos. The brilliance persisted for hours before fading to a dull red ember, but the afterglow lingered, a radioactive whisper in the void. What struck researchers most was not just the violence of the event, but its implications. 3I Atlas, like its predecessors, had come from the stars. Its composition carried the fingerprint of alien chemistry, materials forged in a different stellar nursery. The collision had cracked open a cosmic fossil, exposing its interior to scrutiny in ways no mission could have achieved. Spectral readings suggested elements and isotopic ratios inconsistent with anything found in our solar system. There were traces of rare metallic compounds, crystalline silicates altered by centuries of cosmic radiation, and even signs of super-dense material that hinted at prolonged exposure to neutron-rich environments. Each reading was a clue, each spectral line a whisper from another world. The light that radiated from 3I Atlas wasn't uniform. It pulsed in irregular intervals, as though the object itself were breathing, cooling and reigniting in waves of thermal convulsion. This suggested that the impact had not merely vaporized material, but had driven internal reactions, releasing pockets of trapped gases and volatile substances under immense pressure. The rotating fragments emitted jets of plasma that spiraled outward like luminous arms, painting delicate filigrees across the dark canvas of space. To observers, it was both beautiful and terrifying. A ballet of destruction, illuminated by the raw energy of cosmic collision. Scientists soon began constructing models to understand how such an impact could have occurred. The interstellar void is vast, and the probability of two bodies colliding in such emptiness is vanishingly small. Yet, in the chaotic outskirts of our solar system, in the region of the scattered disk or Oort cloud, gravitational perturbations can hurl objects into intersecting paths. Perhaps 3I Atlas had brushed close enough to the sun's gravitational well to cross the path of a long-lost asteroid or rogue planetesimal. The angle, velocity, and timing aligned in a cosmic lottery that ended in an explosion of light. It was as though fate itself had orchestrated a demonstration of celestial violence for human eyes to witness. The visual spectacle drew comparisons to classic astrophysical events, miniature analogs of supernovae or gamma-ray bursts. But this was no distant cataclysm, millions of light-years away. It happened within our cosmic backyard, on the scale of an interstellar messenger that had once passed unnoticed among the stars. The event allowed humanity to observe for the first time how objects from different stellar systems might interact physically, how alien material behaves when subjected to energies and forces familiar only in the crucibles of stars. It blurred the boundaries between cometary physics, nuclear processes, and planetary science, forcing researchers to rethink what cold interstellar matter might truly contain. The luminosity curve of the event was unlike any recorded cometary outburst. Most comets flare due to sublimation, sunlight heating ices that vent gas and dust, but 3I Atlas's glow was sustained by thermal and radiative processes, complete